Trial and improvement is a method of solving equations. To do that, we kind of use guesswork. It's a formal method of guessing, and it's we pick a starting value, we input it into the equation, and then we see what the answer is. Depending on whether it's too big or too small, will depend whether we increase our guess or we decrease it. And by continuing that process, we can find a very good estimation to that. So the first thing we do is we substitute a trial value into the equation. It's always a whole number at this stage. Improving that value to get a better answer. And once we have two consecutive, so two numbers that follow each other, in between the solution lies, so in other words, one would be too big and one would be too small, then we go to one decimal place. So if, for instance, our guess worked out to be between 3 and 4, then we would go on to look at 3.5. And then again, depending on whether it would be too big or too small, we would then go back and try another value. Once we have it between two values to one decimal place, for instance 3.2 and 3.3, it might appear that it would be closer to, say, the 3.2. What we need to do though is we need to test by going halfway. So in this case we would look at 3.25, and then that would help prove which value it is closer to. There is a quicker method to do this with your calculator, and that's to type in your guess first of all. So if your guess was 3, you would press 3 in the calculator and then press equals. And what that does is it stores it as an answer. So if you were to use the ANS button on your calculator, that would produce the number 3. But what we can do is we can write the equation, and anytime we have an X, we write the ANS or press the ANS button. That will form the equation in terms of ants. And then all we need to do is press the equals button once that's been done, and it will substitute your value of 3 in. We can then change new values, so you can then press 3.1 equals, and then push the up key in your calculator, pressing equals again, and that will substitute your 3.1 into the answer equation as such. So that's just a quicker way in doing that. So to this first example then, we're trying to solve x squared plus x equals 83, and we're trying to use x equals 8 as our initial trial. So what we'll do now, it's been done for us, but I'm going to press 8 and then equals on my calculator. I'm then going to press ants and then the squared button, and then plus ants and press equals, and I get 72, which is what we had expected. I'm going to try 9 now because that value is too small, so on my calculator I've just pressed 9 and pressed equals, and that has stored the 9 in as my answer button. I'll push the up arrow on my calculator, and it's on the screen it says ants squared plus ants. I'm going to press equals, and I get 90. So that was 9 squared plus 9. And I can see that that is too big. I'm going to go halfway then, because the 8 and the 9 are either side of the 83. So I'm going to go 8.5, press equals, push up, and I get, so at 8.5, I get 80.75, which is too small, because the target number, remember, is 83 we're trying to get to. I'll then go to 8.6, and that gets an answer of 82.56, which again is too small, but we're pretty close. We're going to try 8.7 again, so I'm going to press 8.7 on my calculator, press equals, push up. I can see ants squared plus ants on the calculator screen. Pressing equals gives me a value of 84.39, which is too big. So what we can see is that we've got 8.6 and 8.7, and we're either side of 83, and it would look as if 8.6 is closer, but as a check we need to go halfway, so we need to do 8.65. I'm going to press that in my calculator, press equals, push the up button, press equals again, and the answer works out to be 83.4725, which again is too big. Therefore, the answer is indeed 8.6. Before we start into the second example, which is 2x cubed equals x plus 1.8, it would be easier for us to write that as 2x cubed minus x equals 1.8. So then in that way, what we're trying to get is our target number of 1.8. So we're going to start off with x equals 1. I'm going to press 1 on my calculator and equals. I'm going to push then 2 answer cubed minus answer, so that's the formula for it, and I press equals and I get an answer of 1, which we know is too small. I'm going to try x equals 2, push up on my calculator, press equals, and we get an answer of 14, which we can see is much too big. We'll try 1.5, and we get a value of 5.25, which again is too big. 1.4, we get 4.088, which is too big. 1.3 is 3.094, again too big, but we're getting closer. 1.2 is 2.256, which again is too big. 1.1 works out to be 1.562, which this time is too small. So it's looking like it's in between the 1.2 and the 1. And we would think that it's 1.1 because it's closer, the 1.56 is closer to 1.8 than 2.256. But as a check, we need to do 1.15, and that works out to be 1.89175, which again is too big, and because the halfway point is too big, we have to go with the smaller one as we expected. So x is equal to 1.1 to 1 decimal place. To do example 3, where we've got a rectangle which is 4 centimeters more than its width, it would be a good idea to draw out a rectangle first of all, so that we know what we're talking about. The length is 4 more than its width. If the width is x, so this is x, and this is going to be x, the length then is x plus 4, and so it's the bottom one. Given that the width is x and the diagonal is 12, so we'll put in the diagonal to be 12. Find the width of the rectangle correct to 1 decimal place. Because this is a rectangle, we know that each corner is 90 degrees, and what we have here then is a right angle triangle. And we know that for right angle triangles, Pythagoras' theorem holds. So we have that x squared plus x plus 4 squared equals 12 squared. Now we could simplify that to x squared plus x plus 4 squared equals 144. And we could manipulate this further, expanding out the x plus 4 and collecting like terms, but really we don't need to. Since we're using a calculator anyway, we can go then to our table of values. So we'll have x, and we'll have the answer, so it's x squared plus x plus 4 squared, and then too big and too small. So what we could do is we could try a value of 5 first of all. So I'm going to press 5 on my calculator and then equals. I'm going to press answer squared plus and then a bracket, answer plus 4, close a bracket, and then squared, press equal, and I get an answer of 106, which I know is too small. x equals 6, so 6 and press equals, and I get an answer of 136, which again is too small. 7 then is a value, it works out to be 170, which is too big. So what we know is the value is going to be between 6 and 7. We'll try 6.5, and that works out to be 152.5, which is too big. 6.4 next, and that works out to be 149.12, which again is too big, but we're very close. 6.3, and that will work out to be 145.78, which again is just too big because our target number, remember, was 144. 6.2, and that's 142.48, which is too small. So what we know then is it's going to lie between 6.3 and 6.2. It would look as if it's possibly the 6.2. It's 1.5 away. It's 1.5 short, whereas the 6.3 is 1.78, too big. But we're not quite sure, so in this case we definitely do need to do a check, so we'll do 6.25. That works out to be 144.125, which is too big. So because 6.25, the halfway point, is too big, that means that the 6.3 is too big, so the answer is going to be 6.2. So the width of this rectangle is 6.2 to 1 decimal place, and the length is 10.2. And just a note on this, that whenever we are solving linear equations, we get one solution. So something like 2x plus 3 equals 4, there's only one solution. A quadratic, so anything involving x squared, could have 1 or 2 possible solutions, and a cubic could have up to 3 solutions. But whenever we're doing trial and improvement, all we need to do is find one possible solution, and the question will very often tell you exactly what we need to do or where to start. So it should be obvious as to which answer you're going to get.